All right, do have some sound, and we're over here today. This is the uh, virtual Wednesday in Management 3603, and we'll be covering some material. I'm starting 4 or 5 minutes early, and we'll go on a little bit further today than usual. But of course, if you need to bug out or you need to come in a little bit late, that's the beauty of this. The recording is there for you to see when you need to. Now, on the 13th, and I'm just some logistics here, par nonlinear needs to be uploaded. And let's look at that for just a moment, okay? And what I do is I ask you to use a what-if analysis tool to obtain a value of 65,000 in cell B18 in the par nonlinear file. And we went over this Monday of where to find the file, etc. In addition, I also talked about what we're meaning when we talk about a nonlinear approach, and we went through the chapter there, and we saw that that assumes that the data are distributed in either a concave or convex fashion, okay, not a straight linear fashion. And so and the text covers that in quite a bit of detail. And the par nonlinear file is over there in the files, okay? And Appendix 2, 407 through 409, Appendix 8.2, pages 407 to 409 give you a long, a pretty detailed look at that issue. Now, that being said, let's go back over for just a moment to the module. All right. And we'll scroll down here and take a look. And so far, I have no one joining me, which is a little disconcerting, but hey, today's chapel day and all those kinds of things. And I understand I'm starting early, and this class goes, 11 to 11:50. So it's Wednesday morning, and it is 11 o'clock, and you should be here. The second assignment that's due on the 13th is the cluster analysis. Okay, and let's open that up for just a minute. Okay, and there's really no content there. I just want you to upload the cluster analysis file. Okay, now again, as usual, you're seeing some things that you would not normally see if we're in the student view. Okay, and so I'm staying in the instructor view. So next week I'll have a key out there. I have a key for par nonlinear. And I might as well just go ahead and make this published. Yeah, hi, and glad to see you join. Let me see who we got here. If it will pop up for me. Oh, okay. Bo, glad to see you there. And I started a little bit early, so you can always double back on the front end of it and take a look. I'm going through what we have due on the 13th, which is the cluster analysis file. That's out of the Data Smart text, and then the par nonlinear. And the instruction for par nonlinear there. And just to make sure that you and everyone else is on the same page and understand, let's go back over here, first of all, to the files, okay? And we're going to come down here and we're going to find the files for the big textbook, okay? And that's the Introduction to Management Science textbook. So we'll find that here in just a second. Here they are, the web files. All right. I'll download those. And that's over, I believe, in Chapter 8. I think, yeah, we're in Chapter 8 because this is Appendix 8.2. So what I'm going to ask everybody to do is to use the par nonlinear file, okay? And to use the goals, to use one of the what-if analysis tools, okay? I'll click on data, we'll click on the data tab, and we'll come over to the what-if analysis tools, and to use one of these except for the data table, exclude it, but use Goal Seeker Scenario Manager to get maximum profit to 65,000. Okay, and I talked about the case and what's involved with power nonlinear, and again the textbook chapter 8. We use the term nonlinear because in chapter 8 we begin to look at data that don't follow the familiar pattern of a linear trend. In other words, an X and Y and it heads up in a linear fashion. We're talking about concave and convex outputs data, and so we'll want to take a look at that. Now, that being said, okay, we also are going to be looking at, and we'll do it again some more today, at the Foreman files, and page 36, and this is the Data Smart text, okay, and page 36 shows you where to get those files, but I've also uploaded them over here for you, okay, and we're going to download. We can download those, and both of these are due the 13th, okay. Now, the Foreman file, if I'm not mistaken, is in the file that we're going to be working with, is in chapter 2, and I'm going to open this up, okay, and you guys will want to open it up and save it to your desktop and then upload it for the assignment. What I'm going to do today, I got it started on this file, and just to talk about this. And the reason I incorporated this textbook, and see, I've got someone else who came in. Bo's here. Okay, Suzanne, glad to see you here as well. Thanks so much. And as I mentioned, one of the reasons the primary reason that I added this in on this textbook into the course was to show you some advances in management science, particularly in dealing with what we would call non-structured or unstructured data. And as you're going to see, these are data that may or may not lend themselves to a way. These are data that may not easily be tabled or dealt with in that fashion. Now, I also wanted to show you, okay, out of his textbook, I think some excellent ways or examples in which we take a model, and it's usually from the sciences, okay, and we apply it to a management problem. And in this case, this is chapter 2. What we're in the cluster analysis, okay, and chapter 2, this is cluster analysis part 1, okay, and that's one, and we're going to use the k-means to identify customer segments. So for those who in the class who are marketing students, this ought to be all hands on deck, tremendous attention to it, because we're going to see a way that we can use a model from the physical sciences, and that is Euclidean distance. You go, oh no, not geometry, I understand, okay? How we can use that to determine distances between people in a network. Now, the network of people, you say, what do you mean? If you open up this first file, okay, and it says offer information, and you start to see the data. If this was in a database, we would call this, okay, we would call this a dimension table. Why? Well, we have the type of campaign or the month that occurred. We'd have the type of wine that was being sold. We have a minimum quantity. We have a percent for the discount. We'd have the origin, that is, where did the wine come from, okay? And then was it past its peak or not? And those are dimensions, okay? Now, one could argue that because we have different wines sold in the same month, it's a fact table, and I wouldn't quibble about that, okay? But as as we did, as we again, as you remember, this is a promotion that's being offered. So I suppose you could say it's a fact table, but that's almost that's splitting hairs. But what it does tell us is, okay, this company is selling this stuff and it offers a discount. Now, what they're really driving at is, can they segment customers, okay, on some basis? Can they identify market segments? Now, the technique that he uses here is extremely unique, but I think it's a robust technique, and I think if I were a marketing student, this is what I would use if I had to use something in real life, for a simple reason. Most of the time, the way that we develop a picture of a market segment is we'll try to use some type of linear process, like a correlation coefficient or something of that nature, okay, which is fine, okay, but what it does is it compares every single case, okay. So, oh, this sounds too much like statistics, my head hurts. I understand. We take each case and we look at the extent to which each case is or is not an outlier. The data, do they hug that line of best fit? If you took business problem analysis with me, and you remember we did that case where we looked at how much they produced. It was company how much they produced versus the percent defective. And remember we had that XY plot. Same story here. So he goes through that issue, and again, I incorporated this because, first of all, he shows us how we can do some really cool stuff with Excel in dealing with what we call unstructured data. And number two, he's very, very sound from a management science perspective. You remember, and I'll harp on this always and always, always. Management science is really laid out. Its concept, its core, its thought processes are laid out in the first chapter of that text, where it says we look for a model that we can apply. That could be an iconic model, it could be a statistical model, it could be a full scale model, or some scaled type of model. And we do that to say, okay, here's what we think reality looks like, or here's what we want a reality to look like, say a capital budget, okay? And then we ask ourselves, how are the relevant data distributed out in space? Because that tells us how they're related to each other, okay? And so when we talk about, for example, in chapter 8 about concave and convex data, we're talking about data that tend to be like an ellipse. Now, they tend to go up and go down, or go down and then go up. Okay, that's again concave and convex. And if to give you a good example, if I were to go on a whiteboard here, which I can use, which is so clumsy, and I apologize, I got to get better at that. I could draw you an X and Y axis. I can show you that marginal revenue arcs upward. Okay, it goes upward till it hits a high point, and then it begins to diminish. We know that because of the law of diminishing returns. Okay, we could flip that and we could talk about marginal cost. And we know that marginal cost looks like a cup. It starts to drop when we get with economies of scale and experience, and then it comes to its lowest point, and then it starts to go up. Okay, so we assume data are distributed like that. Okay, so we in the par nonlinear, we're dealing with nonlinear data. In this case, all right, the Foreman text, the cluster analysis, we're trying to use a technique from geometry that measures distance, and what we're assuming is that the numeric distance is indicative of some type of clustering effect. Now, I'm sorry I got to spout so much statistical jargon at you, okay? But to really grasp this and see how important this is, you got to follow along with me here. Okay, and you're all smart people, all of you, so you can do this. Look, when I look at these, when I look at who took what offer, in other words, who acted on the discount that was offered, what did they buy, when did they buy it, who were they? When I start to see groups of people buy the same thing at the same time, I see I have a market cluster. I could perhaps even argue that I see a market segment. Okay? Now, this whole file, okay, this whole exercise he goes through in chapter 2, using Euclidean distance, is just the guy. This is a young guy, and he's so smart it's scary. But he's spot on in doing this, because he's saying, I'm not asking questions like your feelings about the product, or do you think you'll buy the product, or would you like to buy the product, or tell me about what you see in the product. No. He's operating on the most fundamental premise that of all businesses, everything starts with a sale. No sales, no company. No sales, no market. And so he's dealing with real data. Now, we call these unstructured data, okay, because they don't necessarily lend themselves to an XY chart. We're not going to find correlations. Now, let me say this also. This case would be a prelude to going out and getting some psychographic data about these people. In other words, do we know an age range? Do we know where they live? Do we know what their income level is? That type of stuff. And then we start to look at that. And we begin to see, did the people who took this discount, this very first discount, do they live in a particular part of the country? Do they seem to have a particular level of income? Do they have a particular age, or etc.? Now, you can go get those data on a follow-up. You can also go say, okay, well, you know, what credit card did they pay with, or did they use a debit card? These are facts that a marketer wants to get as much information as they can get, so they can figure out, who am I selling this stuff to? Okay, so this case is really, you would have to say, would be a prelude to a lot. Now, we did a little bit of work on Monday, where we took these data and we used a sort, and we sorted them out. Okay, and so I don't feel the need to do that. If you want to, you can always go back and see that in what we did. And then we came to this transactions. Okay. And what we did here is we took the customer's last name and we sorted them according to their offer. Now, we put the customers in, and what this looks like to me is that they are, and you can take a look in the book, he'll explain this to you as we go along, and this is over in chapter 2, by customer last name in ascending order, okay? Although it just doesn't appear to be that way. But he's got them in customer last name and then the offer number. Now I'm going to pop over here and look at the custom sort and see if I can discern what's going on here. And I can't. So now he's got the transaction. So let's go over here real quickly. Now he talks about cluster analysis the first few pages of the chapter, okay, and uses that he tries to be funny, he uses a goofy thing about the dance, and he shows us the optimal means, okay? And then over on page 36, he starts with the initial data set, okay? And then here on page 38, figure 2.8, he gives us a list of the offers taken by customers. And I did a custom sort there where I sorted them by offer, okay, from the offer number and then the customer number, okay. And he came up, and he just did just kind of an initial look, okay. And here's what he was after, okay. He's what's Smith buying, okay. What did Johnson, how many offers did Johnson take a bite on? And this would be like him. I go to the lake, and how many fish did I catch? I mean, that's, he put out an offer. Jones didn't buy that. Miller, whoa, Miller's into discount booze all the time. Okay. And Davis, okay. There's Martinez, there's Taylor, Thomas, Hernandez. He's kind of who self-selected into the discount by exercising it. So that, and that's there in figure 2.8. Then we start to come into the point where we start to analyze these data. And he comes to the pivot table, okay? And what he did was he set up a count, okay? This is figure 2.9 over in page 39, and he gets a count of the offer per person, okay? And I did something there, all right? And we'll do this again, okay? And I'm going to just scroll back, and we're going to diminish it down a little bit more. I'm going to take it down a little bit more. And you can see clusters, okay? Now, it's not as easily discernible as, but you can see that there are some clusters here. And so we start to say, okay, well, how do we process these data? Well, one of the things we could do would be to use what we call a non-parametric statistic. We could use a chi-square, or there are some others that deal with nominal data, counts, because that's all we have here are counts, okay, which is fine. But what he said is, rather than use a statistical model, which is what a chi-square, for example, it may be a used one in statistics. A chi-square is a statistical model. It assumes a certain type of distribution, okay? Just like standard deviation assumes a particular type of statistical model. And he said, is there anything other than statistical models that I could use? Yeah, I've got one out here. It's called geometry. It's called the Euclidean distance. And I can measure the distances, the points. Now, what he does, everybody, is he takes that concept that we use out in mapping, okay? When you go to Google Maps, you say, what's the, get me to wherever I'm at point A, get me to point B. And it gives you the directions, okay? And it gives you distances. It is normally using Euclidean techniques to give you the distance so that you know how far it is. And so he says, maybe that would be a way to measure the distance between these clusters. We have we have a bunch of people here. We've got some people here. And then he says, we're going to use the k-means to compute that as well. And really what chapter 2 is he walks us through each of those tabs. Now, let me say this. Okay, I'm going to make a commitment to you. I want you to have every opportunity to understand at the most practical basis what he's doing here, okay? Because it's not just about running the statistics or it's the mindset. That's what's important. What he did is he said, is there something out there in the real world that provides me a model, okay? And that gives me a mathematical model and a real world model. and he came upon Euclidean distance. And he also came upon a very important social or a important social sociographic kind of point. Birds of a feather flock together. Okay, if you and I use the example of Monday. If you drive into Oklahoma City, you're going to see a whole bunch of tall buildings in one place. Why? That's because functionally, that's the central city, okay? And those types of buildings serve a particular type of purpose. And then if you go in some other parts of Oklahoma City, okay, you'll see some clusters of big or certain types of buildings. And you know, if you go down 35, you'll see the mile of cars. Now, all these car dealers on 35 headed into Norman. Why? Well, they all clustered there. Okay, and we know, and I took you guys out, I think, and you probably, if you've had a class, you've seen me talk about or heard me talk about Esri Tapestry. And if you've been in my office and you've seen that tapestry banner hanging down, it shows the clusters of wealthy people. They all live together. The folks that live over in Nichols Hills, the folks that live over in Heritage Hills, they have and they fit a particular profile. The folks that live out at Quail Creek in Oklahoma City fit a particular profile. The people that live down by the campus at OU and the homes fit a particular profile. Now, the amazing thing is that on the whole, en masse, human beings behave very much alike. But incredibly, this is the image of God stamped in you. On an individual basis, we're all very different. In fact, we're uniquely different because we have different DNA. Okay? So I make this commitment. This class goes from 11 to 11, so it's 50 minutes. And what I will do is, if I can't get through this whole thing, okay, then I'll make a part 2, okay, that you can view as well. Now, let me say this. I know that listening to me lecture, because I have to sit here and listen to it too, can become a tedious affair. I understand that. So let me recommend that you do this. Listen for 5 to 10 minutes, then stop. Okay? Then listen for another 5 or 10 minutes and then stop. And then maybe a little bit more. So you can chunk this out, take notes, or stop and think about what I'm saying. Okay? And I've structured the course so that you can do that. If you wanted to today, you could upload the you could do the power nonlinear quite easily. Okay, upload it and it's there for the 13th. You could take this cluster analysis file, you could upload it, and so you have, if you have any exams to do online, you got to do some work with those. Those are open book, open note. But I've structured this so that if you want, you could say, I'm kind of curious about this, or I didn't quite get it. I want to go back and replay it. Okay, this is different from a lecture where it's not recorded and you're taking notes, scribbling down furiously, trying to figure it out. This gives me an opportunity to talk on a deeper level with you about these cases and what we're doing. Because management science, okay, and analytics are the key to success in business in the 21st century. Those are the rules. I didn't make them up. I just want to help you be able to play by them and use them. Well, we've got the pivot table, okay, and then we come into the matrix. Welcome to the matrix, I know. And I make some stupid jokes. I understand that, but that's my prerogative. And you can always scroll forward or back. Now here we see everything, the entire set of data, the offer number, and that's all over there, the deal description and the purchase data. That's over on page 210. Okay? And that's, figure 210 on page 40. Okay? Now, I'm going to click on column G for just a minute. All right. And let's look at this. You say, what is this about? Okay. Well, what we're trying to discern is, will these people buy wine on a discount that's old or new? When we say past peak, what we mean is kind of an expiration date, or it should be consumed by, whatever. And wine is a perishable product, okay? Just like bread is a perishable product. And so it has a peak. And then at that point, the product begins to deteriorate. You take a loaf of bread, you put it in a drawer, and you let it sit, it'll get mold. Wine can go bad, beer can go bad, because they're perishable because they have yeast in them, or they have grapes that can, and the whole process of fermentation. You said, Dr. Harmon, you know a whole lot about this. Yes, I do, because one of my best friends for the longest time was a distributor, and so I learned a lot about the business. Okay. Now, that being said, all right, so we're asking, will they pay a discount for old stuff? It's like day old bread in the store. Now, I'm going to click on the, and they have frozen the pane. And let me show what we did here, okay? He's got this, so the pane is frozen. And I'm going to click on the view, and you'll see the freeze panes here. And this is the way we keep a portion of the sheet visible. Now, there's stuff out on YouTube will show you how to do it, but the author has done this so he can maintain the columns, okay? And he's got, and I'm going to click on freeze panes, and we'll see, and we can unfreeze them or something, but he's set these up so we can scroll through the offers, okay? And so this is, now again, to get a view of it, we can pop down here. And I always suggest that you do that, all right? This is a pretty big data set in terms of rows and columns. So, you know, we're kind of working our way back up here, and we'll move this back up, and we'll take it back to 100%, or close to 100%, okay? And the whole point is we've got all the data laid out. And again, now we really have a data set that we can do some work with. And so we're going to look at the first cut on this. This is the matrix, and we're in 4C. Now, let's talk about what we've got going on over here. And he's going to explain that to us over on page 42, okay? And that's figure 211. Now you'll see at the bottom, okay, watch. At the bottom of page 42 and the top of page 43, he shows you how we compute Euclidean distance. Now, all of you know that I'm a map and weather freak, okay? I'm a geography freak and a weather freak. And I've taken a lot of courses on mapping and geographic information systems. I've taken a lot of courses from Esri, etc. And I want to say this: when we try to compute miles, there's more than one method by which miles or distance is computed. And the miling and the mapping technologies, say like what's used in Google Maps or whatever, people who are cartographers, folks that make maps, have some arguments with some of them, but we're going to do a rough and dirty cut here, and we're okay with it. Now, I want you to notice something. First of all, at the bottom of page 42, you see a cluster center, okay, and a dancer or someone at 8-2. And then he shows us in figure 213 how to compute that the Euclidean distance. And he tells us it's the square root of the sum of the square distances in each single direction. And it even shows us the math there in the middle of it. So that shows us the distance. Now, when we use k-means, what we're doing is we're taking all those differences and we're trying to find what's the typical or average or mean distance and assign them to a cluster. Okay? And so over here on the 4MC, okay, he's got some blank clusters put in the tab, okay, and then we begin to do some cluster analysis. Now, I've got some materials there that I uploaded that explains each of those tabs and goes through them, and you'll want to take a look at them because it can be a kind of a tall drink of water. What's the right tab and all that business, and how's that done, and so you'll want to look at that. Now, let's look at one of these clusters in here. Okay. All right. This shows you what cluster they belong to, and their distance from the center for cluster 1. Okay. Now he's using some conditional formatting to find those, okay, that have the higher or closer distances, excuse me. Now to see this work itself out, he's got distance to cluster 1, cluster 2, and then the assigned cluster. Now let's look at this at the bottom here and we'll see. Here he's going to use the square root, and he's using the Euclidean distance, okay? And he's going to get the square root of the sum of all of those. And that's the distance for atoms to cluster 1. Okay? Now next, he does the distances for atoms in terms of cluster 2, the distances in terms of cluster 3, okay? And you can see there's that same, and what he's done here, and he goes through this in the book. He talks about using Excel, and look, he's got these, he's got the brackets. So what he's doing is he's mimicking or creating a function. Okay, so don't get too hepped up about that. You really want to explore the depths of it. Go back into chapter 1 where it is a review of Excel. Now here's the distance to cluster 4. And here he uses the minimum of those. What's the minimum? And then he assigns a cluster using the match function. Now, let's click on that for just a minute. The match function, and if I'm not mistaken, I give you some verbiage in there about that. And you can look. You can also go out and go to Microsoft, excuse me, and get. You can do help on the function. You can go out to YouTube and see how does the match function work, etc. Okay, so the lookup value is L38. Okay, and L38. Okay, and we have the L38 right there. Is the minimum cluster. Okay. And the lookup array is L34 to L37. It's these figures here. And the match type is a number, 1, 0, or -1, indicating which value you want to return. And I'm going to click Help on this function. And they'll give us some examples. Okay. They'll even give us a little, maybe even a little video thing if you want to see that. And when they talk about the match type behavior, match is the first value that is exactly equal to the lookup value. So we're looking for an exact match. Okay. And the most exact match is 2. Why? Because he said, why isn't this one? It's because 2.012, okay, is smaller than 2.166. And this whole thing just applies across the board for every single person. The Adams family over to the Young family. And notice again, he has a freeze over here that lets us see those distances, and nicely done. This is laid out quite well. Now he applies conditional formatting, okay? And I'm going to just simply highlight this whole thing. And I'm going to click on home, and then I'm going to click data. And I'm going to come to, is it going to be the formulas? My brain is dead today. Home, and here it is. Home, and then conditional formatting. Help me. And I'm going to manage the rules. And what it says, he's going to use a color graded, a graded color scheme. Okay. K2 to 33, J2 to 33, IH, on and on. And he's using a color gradient for these. Okay. Now, over on page, and by the way, he talked the distances and the distance calculations are over. He talks about those page 44 and 45, okay? And then in 46, he talks about, solving for cluster centers, okay? And using the objective function, okay, to do that, all right? And so let's pop over here for a minute and click on total distance, and it's the sum of those, okay? And then we're going to click data, and we're going to click solver, okay? And we're going to see set the objective function A36 by changing variable cells H2 to K33, okay? And we're going to find H2 to K33, subject to the constraint that H2 to K33 is less than or equal to 1. And in this case, we use an evolutionary, i.e. a nonlinear model. And he talks about that over there on page 46 and 47, and then 48 and 49, trying to make sense of it. Okay. And so we're trying to make sure that we get the minimum distance. What would that all look like? So these figures, the cluster figures, okay, come from the optimization where we're doing that. We're looking for the minimum distance. Okay. Now I know that I've been going a while and we're getting to 1137. So as I promised you, what I'll do is, if I need to do 2 parts for today to finish this, I will, because I think it's important enough that you see how he does this. Now, I think we can get through it pretty well because you do have the text to work with, okay? And that's the first cut. Now, here we start to look at and I have a lot of supplementary material there for you to work with, okay? But again, we apply the conditional formatting to get the larger distances, okay? And I'm just going to go back over here to home, and I'll click conditional formatting, and I will put manage rules, okay? And they'll be graded in a color scale. And you can see those. But again, we get these figures from the optimization. Okay, and we use the match down here to assign it to a cluster the smallest. Now you say, well, okay, what's going on here? Okay, and this is kind of an interesting this is an interesting one. We have the match for this one, and we end up with a match of 3. Okay, and that looks a little bit different. Okay, so let's click on there for a moment, and we're going to look up the value M38. Okay, let's find M38. And there's M38, the minimum distance cluster. That's the smallest, and there's a tie here. Okay, and we're going to assign them to a cluster, and we're going to use the match. That's the minimum number. Now we'll use the match, and we're looking up the value of M38, and we're going to look at M34 through 37. What's the closest to that? And then the match type, and that goes to, and it's assigned to cluster 3. Okay, and that's the one it's most closely aligned to. And again, we have this tie here. Now here we have another where it's assigned to cluster 1. And so we're taking the center data, the cluster centers, and based upon where they're at, okay, we just assign them. So far so good. Now this would be the top deals by cluster. Okay, and here we have the deals, then information about the deals, and then the clusters. And then we just simply use conditional format on the counts to identify the smallest and the largest. Do we use a gradient? And this is, we're going to show everybody, it's, we're showing all of them, and we just use a conditional format. Notice, the bigger the number, the deeper the green. And we can back down from this just a hair to get a better feeling of it. But it's not absolutely necessary. Okay. Now, I know it's 11:42, and we'll be getting up to that point where 11:50. And so if you have to bug out, do so. What I will probably do is I may try to finish it and go over the full 50 minutes. But let me say this again. Make use of the materials I've got over there that explain it. It's a bunch of PDF documents I've uploaded over there, and you ought to be able, and you can see them, and I go through exactly, I summarize a lot of what he's got in the textbook. Okay, and again, we're looking at these top deals by cluster. Then we get the distances. Now this one's a little tricky until you understand it's a matrix. Watch. Atoms versus atoms is a 0. Okay, it uses a diagonal. See? And so we're using a comparison matrix. And this conditional statement up here, my friends, is a whopper. It uses a square root, the sum function, it uses the offset function, and it uses that with the data from the matrix spreadsheet. How do I know? Because I see the matrix, and with the exclamation points means the matrix spreadsheet, then H2 to H33, then we're using the distances function, and that is a lot. And I have a very long, I have I have a PDF in there where I explain the entire thing. Okay, I give you a schematic. I walk you through the matrix function, what it means. But basically what we're doing is we're looking at the distances between all of these purchasers. We're comparing them against each other. Okay, and where do they fit? And that allows us then to build what we call the silhouette. And we'll click on that. Now the silhouette uses the objective function, okay? And you'll click in here and we'll go on data. And we'll do the data analysis and you'll see it, pardon me, not data analysis, but solver, where we're trying to get the maximum, okay? For that data set. Okay, and this gives us the average. Excuse me, I'm so sorry. We use the average of K2 to K101. I'm sorry, and that gives us the silhouette values. Now we get the average of that silhouette values. Now to get the silhouette value, okay, we use this equation where we're comparing these distances, and then the neighboring cluster, we use the equal if statement. And I explain all this in some greater detail, okay? And then we use the index function to determine the cluster, and then the second closest, and then the closest, and then the distance from people in cluster 4, people 3, cluster 2, cluster 1. So there's a lot to bite off from here. Okay, so I know that if it's nearly 11:50, I did start early. Okay, and I may just go ahead and slog through this. And so if you have to go, it's fine. I understand that. Don't worry about it. And you can always just scroll to this point and then go forward if you need to do so. Okay, and I have here, we're using the average if, and that's a conditional statement. I'll click on this for a moment. We put a range of data, we give it a criteria, and we average it if it meets that criteria. And remember, when we reference these things like distances, exclamation point, we're talking about the data from the distances cell. So in this case, what he's doing is we're computing the silhouette, okay? And we're looking at clusters or differences using that silhouette. Now, he talks about this, okay, over on page 48 and 53 and 54. Where he talks about it's a way that we can find out how far we are from our neighbors. So this whole notion of the cluster analysis and the k-means analysis is, okay, first of all, how far am I from the cluster center? Okay. And that tells me something about, do I belong to that cluster or not? Then we have a computation, the silhouette, that says, okay, well, how close am I to members of another cluster? And if I'm really close to them, I may not have clusters as well defined as I should. If I'm not, and everything's consistent, I've got my clusters. So this is how we determine, do we need to slice and dice the data a little bit more. Okay? And now, I know this is some heavy lifting in terms of just kind of walking through it and slogging through it. And you'll see I have a very extensive set of notes that I've uploaded there in PDFs that go through all of these different Excel functions that he uses. Okay, and we'll take a look now over at 5. Now 5MC is when he decides, well, for looking at this, we'll go back to the silhouette, all right? And as he talks about the average silhouette, what he comes to the conclusion that it's too big, and well, it's not the appropriate proportion, we put it like that. And so let's cut the data up into fifths, 5 clusters. And so he goes through this whole exercise again, and he comes up with an average distance and an assigned cluster. Then he does the top deals by cluster, just like we did the top deals for 4 clusters. Then we do the silhouette. Now, he compares the silhouette for 5 clusters versus the silhouette for 4. And we haven't made much progress. Okay? So when we think about cluster analysis, we think about how is that position versus the center? How is that point position versus another cluster, members of another cluster? Okay, let me give you a real practical example. My wife and I live in South Oklahoma City. We live right on the boundary of Oklahoma City and Norman to our south and Moore to our east. But we're in Oklahoma City. But we're really closer to everything in Moore than we are to either Norman or Oklahoma City. But we're still in Oklahoma City. So as in the same way, when we identify a cluster, as we did in this cluster analysis, we want to look at a point or data point and say, okay, how close is it to the middle? But how close is it then to members of other clusters? And I'm closer to people who live in Norman, to all the people who live in Norman, than all the people who live in Oklahoma City. And I'm closer to people who live in Moore than the people in Oklahoma City. I'm just across the road. Okay? Well, I'll tell you what, we're at 11:51, and we've been this about an hour. And I know if you have to bug out, you go ahead and have to bug out. But if you want to stay, that's fine. And I'm gonna slog on through this. Now, let me say this. I realize this is going to be quite a recording. It's going to be an hour. So let me recommend again. And this is some tough sledding mentally. Listen, I had to really do some hard digging, and you'll be able to tell that by all the notes I've uploaded over there. I have a lot of file notes for you. Okay, they're in PDFs. It's got my handwriting. So you see, I did the work. My book's all marked up. I just throw this at you. And let's take a look then at the 5 median clusters. And then we take the 5 median clusters minus the top deals by cluster. And this starts to tell us, okay, where do people really fit? Okay? So what I will probably do, and I'm toying with this, is on Friday to make a part 2 of this. Okay? And I probably will do that. Or maybe today, later I'll make one. But I want you to, but let me assure you, first of all, you need to make sure you upload this file for the credit, okay? And I'm going to close this off, and I won't save any of the changes, okay? And I want to make sure that you look over here because I have some PDFs that deal with this case. And let me see here. I'm going to identify them for you. Get down here to here. Okay. It's the Manual Basics Explained. Naive Bayes. No, it's not this case. Part key. Let me walk through here. Okay, the Silhouette PDF, that's one of them. That's a PDF file I have there. You'll want to take a look at it. Okay, let me move this thing up here. Space position. Okay, you want to take a look at that. Okay, and I've got, let's see, what else is in there that might be of some value to. I think that pretty much does it in terms of the files that I've got there for you. And I think I'll walk you through the K distances, tabs, and all that business. Here's the Silhouette PDF. Let me see if I walk you through the K distances tabs. I may have loaded everything up there. I'm pretty sure I did. Here, oh, here, distances. Okay, that's another one. And so those are tabs that those are PDFs that I would encourage you to take a look at. Plus, it's not a bad idea to do exactly what I've done today and go through go through the spreadsheet and go tab by tab by tab. Okay. For a very simple reason. That's how he's organized the textbook. And I think it's going to be worth it for you to do that. And I will probably, I may well do a second screencast. I'm just not sure, so I'm not going to make any promises that I will. Because I think if you take this screencast, you take the PDFs I've got there for you, okay, and you open up the file and you just go follow along with the textbook, it's going to be readily. The most difficult thing on here is swimming through some of those really complex conditional statements. But it's also, I think, probably the toughest is understanding the offset function. And I would say that's the one that will trip you up quicker than anything. And there's a lot of information out there. You can go into the Microsoft Help as we did. You can also go out to YouTube and some other places and get help on the offset function. And that's that one he uses when he does the comparisons. Okay? Well, folks, listen, I appreciate your time. And again, on these cases, okay, the part nonlinear, what we did Monday was fine, but on these cases involving the data science, let me recommend have the book, okay? Have the Excel file in front of you. Be ready if you need to open up the PDFs that are related to this case. This is chapter 2, and go a tab at a time and follow through and see the final products, and you'll start to understand, okay, how he and here's what we end up. The payoff is this: he tried 5 clusters, tried 4 clusters, then he tried 5, and he didn't see enough improvement between the two of them to say, okay, I can really define this as 5 clusters as opposed to 4. Okay? And he just repeated. So he had that algorithm, he just repeated those, and you see that there in the spreadsheet. Well, thank you so much, and don't forget, upload upload the power nonlinear file, and I've got the directions on it. Let's do the 13th, okay? And this file from chapter 2 of the Foreman files, upload it, and let's see what else you got going on. Okay, and that's it. Okay, and those are both the 5 o'clock on Friday the 13th. How about that? All right, my friends, thank you so much. Appreciate you being here, and take care. If you have any questions, let me stop here for a minute because I see 3 people here. So I see Alexander. Do you? I'll unmute all. Alexander, any questions? If you don't have a microphone, you're very welcome to shoot me a text message if you have a question. Suzanne, how about you? Anybody have any questions? Okay, well, I will assume then that you don't. And I will stop the share and stop the recording and see you next week.